Welcome back to the shop, everybody. We've got our next project here that we're getting ready to get started on. And what we have here, this is an adapter plate that bolts onto the back of a drilling head off of a Walker-Turner radial arm drill. And this drill belongs to Tab Adams. And Tab Adams is known as Crosscut Vintage Designs over on Instagram. So if you guys are on Instagram, go over there and check out his page and give him a follow. He is a top-notch craftsman and woodworker. He makes really beautiful high-end wood furniture and shares a lot of that over on his Instagram page, as well as he gets into some teaching of the younger generations as well. I know he has people in, I don't know if recent, but he actually has some classes every now and then where he's teaching people, you know, how to build furniture. So he does love to share the knowledge of his trades there. So anyway, this drill press, this Walker-Turner drill press, he had bought used, said that he had the intentions of getting it cleaned up, getting it running. He's got to install a motor, I believe, and he wanted to use it to have a larger capacity drill press in his shop. And in the process of taking it apart, he took the drill head off of the ram, and this was attached to the back of it there, okay? But at the time when he took this off, he didn't realize this was a separate piece, and then he set the drill head down on the table, and when he did, this piece had come off and then rolled off the table, and it broke. So you can see right here, you got the cracks in here where it actually broke into several pieces, and Tab actually just taped it back together just to kind of hold it all together back as one piece. So I've actually got a video that he sent me explaining what happened, so we'll go ahead and play that right now.
Okay, so this is where the part goes on this shaft right here and attaches to the back of the drill head here. The problem that I had when I took it apart, I didn't realize that part was separate from these two. When I pulled it off, it stuck to this piece here, and then when I set it down, it fell off and hit the floor, and that's how it broke.
All right, so that was a little video from Tab and his explanation of what happened there. And this could very well be a welding or even a braze project if you chose to do that and go that route. But it's also a great candidate to just make a new piece. I think it's simple enough that you could just make a new piece without having to worry about going in there and machining out welds through the holes and slots and all that kind of stuff, you know. So we're just going to make a new piece. That's the option that we picked. And Tab actually provided this piece of ductile iron right here. This is some 6.5 inch ductile iron that he had sent to me. So his material, we're going to use that right there. And we're going to use the Monarch lathe to get this job done. I also want to point out that I've decided I'm going to do a face grooving op when we're in the lathe. So this area right in here, this is where the two T-bolts go down through these slots right here. And that's what allows the drill head to rotate on this adapter here if you want to set the head to a specific angle, okay? But we're going to be doing a face grooving op instead of going to the rotary table and milling this groove in there with a milling cutter. So I've got this tool right here. This is Iscar brand, but you can see it's a blade that goes into the block that you would normally use for, you know, holding a parting blade. But this one is designed for cutting in a face groove. You can see it's got a radius there, and you're good on 75 millimeters minimum diameter up to 140 millimeter max diameter. So this is the perfect tool for this job, that we'll be able to go right in there and machine this face groove out. I'll be able to go in and plunge most of this out, and then we'll be able to go in and, you know, just clean it all up just like that. So this always has worked really well for me. That side right there, it broke on me at some point. I forgot what I was doing, but it snapped the bottom of it off. So we still got one side left, and shouldn't be any problem for this ductile iron to get that done. So after that, we'll go to the do-all mill, and we'll have the rotary table set up, and we'll set that guy in there, and it'll actually be on this side right here. We'll set it down in the rotary table, and we'll get our two holes and counterbores done. This is for your socket head bolt. and then we'll go ahead and mill the 2 slots in there. And I've been laying this out and just making my little drawing of the map there so that I know our dimensions and of course the angles there. So we'll use our center holes there as our 0 location, and then the slots begin at 40 degrees each way, and then they go around 100 degrees each side there. So just got all that drawn in there as I need it, and it should be a fun project to do. All right, so let's go ahead and go down to the Monarch lathe and get this piece of ductile set up and start machining. All right, we've got our forge all preset to our 6 3/4 that we want. Pretty simple right here. Yeah, we'll just get the OD indicated and then get everything machined in one op right here. Go to the bandsaw and cut it off, and then we'll be able to come back to, we may go to the Victor for that and use a 6 jaw, but after we cut it off, all we'll have to do is face off the back side to the right thickness. I'm sure it's going to make quite a few people cringe hearing that, but there's nothing wrong with that sound right there. It's just it makes the sound it makes going across that crust. You can also use a wide radius tip on the end of the indicator there, and it will help it out some. That was off quite a bit on this one. I think we're finally getting it there though. Doesn't have to be exact, we're just trying to split the difference on it. About 20. 40 and 40. That's a little high right there. Yeah. Within a few thousandths of being on center. That one's just a touch high. Snug that one in, and that's going to be close enough. We are ready to go. I'm going to check my tool and make sure that we're on center here. Just come in and face the center a little bit just like that. Just plunge it in and come across, and you can tell if the tip is right on the center, and I've got it good. We're locked in. Just clean the face up. So on the OD, our finish OD is going to be 6 1/4, so we've got about a 1/2 inch to machine off this OD. I'm going to go ahead and turn it back approximately about 1 1/4 inches back, and that'll give us plenty there for our saw cut and be able to chuck this back up and face it off there. Okay, but what I'm going to do is actually, turn it back 1 1/4 inches. I'm going to leave this diameter just a little bit large here, but it'll be machined. It'll all be machined true with this area that's going to be finished, and it also will have a nice clean face there. So that way, whenever we put this back into, say, our 6-jaw chuck over there, I'll have a good face there that I can indicate and make sure that we're actually running true with our previous machine face on this side. Okay, so I just wanted to point that out there. And I'm going to use this carbide, brazed on carbide tool. This is one of my Micro 100 1/2 inch shank tools. This was brand new. I went ahead and honed a nice little radius on the tip of it right there. These tools do an excellent job in ductile iron or even cast iron. I actually misspoke earlier. I was talking about leaving part of this larger diameter here, but there's really no point in it. We'll just finish all this down to size, and then once we cut it off, we'll just face off what we don't need there to finish it to the proper thickness, which is going to be 9/37 or 15/16. I'll go ahead and get a measurement here, and then we'll finish it there on size. And this isn't, all these dimensions really aren't super critical except for the bore. That's exactly 1 inch, and there's a shaft that this thing slips up on and fits it. So we got 55 thousandths to come off the OD there. So we'll do our normal process on finishing it. I've slowed it down to a 10 thousandths feed rate, and this is a 30 thousandths cut, and then after this I'll mic it and then take whatever's left there. So I always try to split it whenever you get down to your finished cut. Just try to split it into 2 equal depths. We'll use a 7/8 taper shank drill to get our pilot hole down through there, and then we'll finish it out with a boring bar. I've already got it spotted in with a spotting drill. We're going to get our 1 inch bore finished out. This is the 3/4 inch bar that was given to me by Steve Barton over at Solid Rock Machine. This is a bar that he makes in a couple different sizes. You've got a screw down insert on one side, and then this other side takes a TPG 300 style insert. So this will work good for that cast iron. So we've got about 120 thousandths to come out of this guy. And measuring the old part, they finished it at like 1/1000th over 1 inch. Just use our telescope gauge and a micrometer. It seems like those chips are trying to stick to that bar. Must have a little magnetism in that bar for whatever reason. All right, we've got a good finished hole right there. We finished at 1/1000th over 1 inch, which is exactly what the original is. So our next op is we're gonna go ahead and machine this face groove in there now. I showed you earlier. I've got this blade that's set up for coming in here, plunging, and cutting this out. I always like to keep my tools indicated. Most of the time you want to be perfectly perpendicular to your work, or in this case in line parallel with the axis of the machine there. So I've got the indicator on the blade itself, and I'm just running it back and forth, and we're off almost 3/1000ths right there. Okay, so I'm going to go ahead and I'm just going to move the compound, not the tool post itself, because that is a very minute amount. Just loosen that up. Won't take much. It's pretty darn close right there. That's not even a half a thousandth across that length there. So I will tighten up the compound nuts here, give it another check, and it looks like we're still in the same place. All right, we're good to go. We are ready to start making our offsets and making our cuts. So I'll point out that we went ahead and just barely got touched off on that corner there. And you can hear that. So I've got to offset at the width of the tool there. But I'll also point out I've got my drawing right up here, and I've got my distances there. We've got our diameters. I know what the wall thickness is supposed to be right there, but we've got our diameters written in there. So I'm just going to be offsetting it the proper amount, and I'll give myself extra to clean up on both sides. What we want to do is just get it roughed out. We'll start with our tool bit, which is 156 thousandths wide, but we got to double that, so we're going 312. There's 3, 10, 12. All right, so now that I've got the tool lined up with the OD of the part, now we'll have to offset it. Our wall thickness is going to be finish out at 375 thousandths, so we'll go in a little bit further than that to get to that position there. So I think what we're going to do is make it so that it's a 400 thousandths wall thickness. That'll give us about 25 thousandths to clean up. So we've got to double that though. So that's 4, 5, 6, 7, and 800. I'll verify that using a trusty old rule up here to make sure we got our proper wall thickness. And we are just over 3/8 of an inch. So we're good on that position right there. All right, let's go ahead and get our touch off on our first spot here. All right, that's going to be our 0 location for our depth. And the depth is 3/8, and that depth is really not critical. It's just an area relieved for the end of the T-bolt to go in and and rotate through there. But we're going to go 370. We'll go 370 deep. That way we can clean the bottom up with about 5 thousandths. So here we go. I'm going to feed this by hand. $50,000, the 100,000, 150, 200, 250. 300, 350. I'm going to stop right there. What I'm going to do is just go ahead and touch it just like that, and just use my scale, come in here, and it's just under 7/8 of an inch on our width right there. So we're right where we need to be. Go ahead and start our cut now. now it's just a matter of coming in here and relieving the area in between. And once we do that, we'll just clean everything up to our finished dimensions there. Alright, so we've got it roughed out now, and all we've got to do is just come in here and finish our diameters the way we want, and then clean up the back. Pretty simple. So our inside diameter here is actually finishes at 5.5 inches, and just as easy as coming here with some calipers and measuring it. Looks like it's right around 5.465 there and about. So we'll just offset the tool, come in here and make our finished cut on this side. I'm going to use power feed there to come in. I still have to make one more cut here to clean it up. I'm going to come into the bottom. Let's feed it in a little bit more. Set of 0. That actually should leave 5 thousandths to face up on the bottom. And I didn't take the whole thing, so we're going to make one more cut right here. I know you probably can't see that, so we got 15 thousandths. That's 485. So 15 thousandths. And believe me, the calipers are a good enough measurement for what that is there. It's just clearance. Dial in another 15. And we'll let it feed in there. That'll be our finished cut there. These aren't large chamfers on these corners. All they did was just kind of break the edge. I'm assuming to kind of, like on this outside, maybe to line up with the machine, so you don't see a big bevel there. That's just me suspicious though. Just break the corner. All right, and break this inside. I have that tool. That tool is ground for doing these right here, so I have plenty of relief under it, so it won't drag on the part there. And just like that, lathe work is done. I know I said I was done. I lied to you, but I want to go ahead and give it a little lick with the Scotch-Brite here, just to kind of brighten it up a little bit. It softens up those corners there as well. All right, it's time to take it out of here, and we'll go to the hide mech and we'll put the saw to the test and see how it does cutting this big thick piece of ductile iron. All right, we're all set up in the hide mech saw to go ahead and cut this disc off. I just went ahead and measured it out. It's approximately 1 3/16 there, so that should give us plenty of material to face off the back side of that. One thing that I'll point out is that when tightening it up, I noticed a very slight amount of lift on this. I still need to adjust the gibs better on this vise right here, but it's got just a slight amount of lift. So I come around here with a dead blow hammer and just bump it down until I can visually see the bottom of this piece of ductile flat on the bottom of the vise. So hopefully that'll help create a nice straight cut through there. So let's give it a shot and see how the saw is going to do. This is the first time I've cut this kind of material in the saw here. Well, that did a good job. It took all of 5 minutes to cut that. The new MK Morse saw blade is doing nicely, and it looks like it's a nice even cut there. I'll do a measurement on it and see how parallel the cut is with the machined face. All right, let's give this thing a measure and see how parallel it is. It certainly looks really nice. All right, so this is the bottom here. There's the burr on the bottom, so the top is right about there. All right, we come up in there and measure that. You see you're right around 100, right at 1 3/16, depending on where you measure it there. We'll come right here to the bottom. Right at 1 3/16, a few thousandths off. But if you come to the side, so this is going to be the middle of the cut right here. All right, you can see it's thicker there, 1 inch 2/15. And if we rotate it around here to this side and measure that, you can see right around 160 or so. So that's about 50 thousandths right there off. What that's telling me is that the cut from top to bottom is nice and straight, but I think the the head is slightly off, just a little bit of an angle off, cutting it, so it's not cutting it perfect. It's cutting it straight, nice and parallel up and down, but I just think the angle of the blade is just slightly off, so I need to check that out. So anyway, we'll go ahead and we'll go to the lathe and finish the lathe workout, get this thing faced off nicely. I'm going to use this Micro 100 3/4 inch tool bit for the facing, and I could tell I had used this tool before. It had a little bit of wear on the corner, so we're just touching it up here on the diamond wheel on the carbide grinder. Really just bringing that radius right back into the tool, and I feel it with the top with my fingertip there. And I can tell that it's getting nice and sharp, and that little burnt area is being removed. Yeah, that looks good. We'll roll with that. We're going to be using the TMX6 jaw to face this out. I love this chuck. I love using it. The only thing that I don't like about it is having to change the jaws around. It really is a chore to do that. But I will say that if you get you one of these battery powered impacts right here, and then the right size, the hex key there for it, which in this case is 10 millimeter, it makes taking these jaws on and off super quick and easy. You just use that to just pull the bolts out real quick and bring it right back in. Clean it real good before you do that. So anyway, let's go ahead and take our workpiece, and we've already wiped the jaws really good. I'll do it one more time with my finger there. Get everything good and clean. Make sure that surface is clean too. All right, and then just for good measure, we've got our soft blow here that I'm gonna just give it a few taps and make sure it's pushed up against the jaws there. I know I'm going to have folks wondering why I'm choosing to use the brazed on carbide tool over a carbide insert tool like this guy right here. Now mind you, they got lots of different inserts designed for cutting cast iron and ductile iron, and those work just good. But those brazed on tools like I use right there are excellent as well. And because of the grind profile, the way that the tool is shaped, you actually, to me, I like the chips that you get. You have better chip control over using that braze tool versus a carbide, especially when you're doing manual machining like I am. So the difference is you're not spraying chips all over yourself and all over the shop, and you've got them in a more compact, controllable environment right here. So it's slinging the chips up and they're landing right here on the the carriage of the machine, and you can see what kind of chips. They're a little bit more, they're a little longer, a little more curly versus the fine spray pattern that you get with a lot of the different carbide inserts. So it's just a personal preference for me. You can use any kind of tool you want, but just from experience, I like having these type of chips coming off this ductile iron. Plus, I've got the tools to use right here, so why not put them to work, All right, our finished cut looks nice. It's super smooth. It is just beautiful. We'll see where we finished it out at. I was shooting for 15/16, and we finished out at .938. So perfect. That's what a thousandths of what the original measures right there. They're at 937. So all we got left is to chamfer our corners, and the lathe work's going to be done. Just break that corner there.